Okay, so we want to find or determine the equation of a quadratic function. And we're going to need some information to do this, right? So given some information, how do we determine the equation?
It's called math, guys, okay?
So
Determing.
Determining, perhaps that's determine in the
Those people yell it out. Nah, I read the page. You know what? We're going to Seattle. I'm going to be watching the
determining. Determining is what Flash Gordon would do. If you've never watched Flash Gordon, then you won't get that. But if you have, then it was pretty good. Okay. So quadratic is in the form y equals ax minus p squared plus q. Let's listen. What do we know about this? Looking at this equation, what can you tell me about it? Okay, so the vertex is PQ. Okay, what else? Then?
It's expansion.
The opens up. If it's negative, it opens down.
You don't know if it's expanded or compressed. Now you could say. Not really.
It's compressed.
There we go.
I don't like compressed and expanded, so I'm not even going to talk about them, right? It's a vertical stretch, and I don't want you to either, right? It's just a vertical stretch by a factor of a about the x-axis, and only if they ask would I then say resulting in a vertical expansion, okay? And even if you're going to use expansion compression, then you probably actually want to modify that with vertical or, I mean, for this year, for our purposes, they're always vertical. Right, but for next year, it could be vertically expanded, it could be horizontally expanded. And if you actually look at a vertical expansion of a quadratic, that's also a horizontal compression. Okay, so that A value can be used to describe a vertical stretch or a horizontal stretch. Works only really with quadratics, and we don't worry about the horizontal this year, right? But you'll see it next year, so it's just something to keep in mind. So if A is greater than 0, it opens up. If well, we should be able to say some more about this. Opens up and then has a what? Has a, so if it opens up, then it has a
Vertex at 0, 0.
this is,
Reflection?
this is, and this is, no, minimum, maximum. So what does it have? Has a minimum, you could keep it the same. Okay, so if A is greater than 0, it opens up and has a minimum. Move this, move that down. Has a minimum value of Q when x equals P. Now, it's the equation of the axis of symmetry. How many M's in symmetry?
1, 2.
One.
Don't trust me, don't trust me.
Symmetry.
Yeah.
No English.
Yeah, no.
Okay, so the axis of symmetry is x equals P, the vertex is PQ. If A is greater than 0, it opens up, has a minimum value of Q when x equals P, and the range will be y is greater than or equal to Q. And if A is less than 0, it opens down, has a what value?
That's a maximum.
Maximum value of
Q.
when?
X is equal to P.
Yep. And the range?
Y is squared, yeah.
Y will be less than or equal to Q. All right, so that's a whole bunch of stuff that we get all of that out of this equation, right? Y equals ax minus p squared plus q. Gives us all of that. We know where the vertex is. We know where the axis of symmetry is. We can graph this thing. We know what the stretch is. We know that if we move 1 unit from the vertex, we're going to go up A or down A, right? Either side. All right, well, you're furiously copying that down, so I'll let you continue to play 15th century monks or whatever it is.
Just copy this one.
Okay, you can play students in the 30s then, let's say.
What does that mean?
Before the advent of any technology where, you know, like I don't know how they copied stuff for students. I don't think they did. You know, how would you have done that before you had any technology capable of copying
I
stuff?
can break in my laptop.
They don't have cars for this one.
Well, you could just take a picture of that and you have
Yeah. Or you could wait for the video and then just scroll through it if you want to look at the notes.
Yeah.
So, you know.
He needs a car for
Oh yeah.
It's like, seriously, I don't know what century you were born in, but it must have been the 20th.
No.
Okay, so.
right with a car.
Born in the 60s.
They have electricity, but they still use fireworks.
given plus HE.
Given the vertex and,
A point. On graph.
no,
It's like Lorraine.
the stretch factor.
Oh, okay.
I know, that's what we said. Gay.
Okay, so let's say that we have a maximum at, I don't know, pick a number, any number.
2-2.
3,000.
Yeah, 2, 2. That's nice, because then we'll be able to distinguish things very well.
Tuesday.
How about 2, -3?
Oh.
Such a terror.
Well, you know, if you use the same numbers, it's like us using the same numbers in a question where then, okay, if they make a mistake, well, they're still going to get the right answer because, you know, so
I see.
we need to make sure that if you're going to mess up, that it is, you know, obvious to everybody that you've messed up. And that way you don't think that you got it right when in fact your thinking is wrong. Okay? Because the more important thing is that, you know, that you learn how to do it and that you communicate what you're doing. And that's how we can figure. So when you get this test back, right, and you've shown some work for something, if you get a particular multiple choice question wrong, you should be able to look at it and figure out what your mistake is. That's how you're going to learn, right? That is not something that, you know, like, because you got a CUME coming, especially because you have a CUME coming up, right? So you definitely want to be looking at this test to say, all right, what mistakes did I make? Why did I make them? What am I doing wrong? Is it a mechanical error? Did I just, you know, I subtracted and I should have added? You know, I divided by negative and I dropped the sign. You know, that's stuff you have to know, right? Is it mechanical or is it conceptual? Do I just not know how to do this? In which case, well, then you have to figure out how to do it properly, right? And that, without that knowledge, I don't know how you learn anything, right? I mean, without knowing what mistake did I make and what did I do wrong and how do I fix that so I don't make that mistake again, right? We're supposed to learn from our mistakes. Maximum at 2, -3 and is congruent to y = 3x². So what's congruent mean? So it's the same shape, right? In other words, we could take this shape, run it through a series of transformations, and end up with what we're going to be looking at here, right? Which would all have started with y = x², and then we know that we do stretches first, so we would have done y = 3x², and then we would do some stuff to make that so it has a maximum point and all that good stuff, right? Okay, so what are we going to do? Draw a diagram. That's a good idea, right? And you guys do this far. Yeah, like you don't do it, right? Like I should have seen diagrams on that test for certain questions, just so you can clarify what it is you're looking at, right? Like you want to do an inequality and you're not sketching out the graph so that you can see where it's less than 0 and where it's greater than 0. Like, you know, so maybe you get it right, maybe you don't, but is that just a 50-50 thing? Like, you know, half of you have randomly guessing, you're going to get it right half the time, okay? Sketching it out, you're going to get it right 100% of the time, right? If you've drawn the sketch properly, if you've drawn the sketch improperly, that provides you information. Like, oh, I drew that wrong, right? I had the wrong end behavior on it. It was a negative cubic, so it should have done this, but I drew it like that, and that's why I got the question wrong. As opposed to, I don't know what I did. And that's what, a lot of you guys are going to look at the test, and you're going to look at a question, and you're going to look at the answer, and you're going to have no clue what you did. You are not going to remember how you got that. And that is sad, right? Because whether you got it right or wrong, you may have got it right for the wrong reason. You just made a series of mistakes that happened to get the right answer. You may have randomly guessed something, in which case you should have a symbol for just that I randomly guessed. Because you look back at that question again, how did I get that answer? I don't know. If you have a little symbol there that you use that just says I randomly guessed it, then you can at least look at that and say, yeah, okay, but I better know how to do this for the next time, right? What if that same question is on the cube? You're going to get very similar questions on the cube, right? So you need to know whether you knew how to do it or not. Anyways, maximum at 2, -3, so we go to 2, -3. And it opens down. And it's congruent to y equals 3x squared. What was this? 2, -3. So we should just be able to write the equation in one fell swoop. So why don't you do that? Write the equation. Don't say anything out loud. Just write the equation that you think this is. Compare your answer to mine. Figure out who's right. Both right, both wrong. Well, wouldn't know if we're both wrong. Well, we could both be. So we could both be right, we could both be wrong. One of us could be right and the other wrong, or vice versa. Okay, agree, disagree? Okay. So it opens down, so we know it's negative. It's congruent to 3x squared, so it has to have the same stretch factor, right? And then the vertex is at PQ, so it's x minus P plus Q with plus -3 becomes -3, right? Okay, all good? Yeah? Concerns? So that's like the easiest one, right? Because, you know, really, what's there to do? So how about given a vertex? And point on curve. Okay, give me a vertex.
13 and -12. 13 and -12. 13 and
I think
-12.
we can hear.
Hang on, maybe I'll just pick this so that we get. No, well, yeah, okay, we'll do one. So let's go 1, -3, and point at 2, 1. Now, depending on how much work you have to do, I'm going to show you, there's a couple of ways we can approach this, right? So one is, what's the first step?
Try it.
Draw it. I like to see it, right? Like, does it open up or down? It really doesn't matter in this case, because substituting the information we have into the equation will yield the right result, but this is a confirmation that, yeah, okay, my A value matches up, and everything's good. Right? So 1, -3, 1, -3. And has a point at 2, 1, so 2, 1.
Wait, what? Why is 2 to the left of 1? Yeah, it's 2, 1.
Okay,
Yeah.
2, 1. 2, 1, details. You know, it's all just
What
details.
if it goes down?
Then it would never
Then it
happen.
would
Well, then it's not going to hit the point 2, 1, is it?
Like,
Okay, Jay.
Go ahead, draw me something with a vertex at 1, -3 that opens down. We'll wait
I'm surrounded
forever.
by
And while you're attempting that, we'll just move on.
surrounded by
That's
myself.
why you draw this, right? You want to see, what does it look like? So it opens up. So I should expect to get a positive A value. And looking at this, I know what A is, but I'm going to show you 2 A's, right? So here's what we do. You start with the formula. Y equals A, x minus P, quantity squared, plus Q. You now fill in the information that you know. And actually, I'm just going to start off filling in part of the information, which is y equals A, x minus 1 squared minus 3. So I'm filling in P and Q, right? That's my vertex. These are numbers I know. I don't even need this diagram, but, you know, I like having it there. Now I'm going to put in the point that I have, because I have an xy value. Right? So if you look in here, there are 1, 2, 3 unknowns. Except, given this point, I now know 2 of them. Make sure you substitute in correctly, right? The y is 2.
It's 1.
Right. I wrote 1. I just good. You're awake, and I'm partially awake. So the y is 1. I did say 2, but I did write 1. The y is 1, and the x is 2. Okay, solve this. What are we going to do?
Too lazy.
9a. Where's the 9? Where's the 9? Wait, what? Oh, wait, yeah. No, never mind. It's 1. I cannot see anything. No, you know what?
I got 3 and 6 like
Okay. So our equation is of the form, it is y equals 4, x minus 1, quantity squared minus 3. So what we do is we go back to here, and we fill in the value of a that we have just calculated. Right, and that gives us our equation. And this is the equation. There is only one equation that does this, right? That has that point and that value. Now, if I don't have to determine this, if I just need to state this, then I can say, well, from 1 to 2 is 1 unit, right? Going from 1 to 2 is 1 unit. And how far up am I going? And therefore my a value is? Right? So when you move 1 unit from the vertex either direction and you count up to the curve, that's a.
So it's like a checking method.
Yeah, well, in this case, because it works out nicely, right? Now, let's do another one. You guys randomly choose, and we'll do one more. Okay, where's the vertex?
8.
Exactly, right? It's like, how do you even think this works? All right, anybody want to attempt a vertex?
Negative 1, 3.
Then we use negative 8, 2. Okay, and give me a point.
7, 3.
Yeah, sure. No, that's fine.
Yes. What happens if the same point on the vertex?
Okay, so it's not on the vertex. It's fairly far away from the vertex, right? It's going to give us a value of a that will not be nice, but will actually be more real, true life, right? So if you think about it, if you see any parabolic arch out, what's with the snow? If you see any parabolas out there, a parabolic arch, you ever been to the U of C? You see they have an arch there? Okay, so maybe that's a parabola. I don't know. There are other equations that it could be, but let's call it a parabola. If it was a y equals x squared arch, then if you went 1 unit this way, you'd go 1. It would look like, you know, the road's like this and the arch is like this. A y equals x squared would look like this, right? And it's this. So real life parabolic curves tend to be more like this, right? So let's sketch this out and just sort of see what it looks like. So negative 8, 2, negative 8, 2. And I have a point at 7, 3. Okay, so does this open up or down? Opens up. Is it expanded or compressed?
I wonder.
It's very much compressed, right? This is why we don't use expanded or compressed, because nobody, you know, right?
Oh God, what?
Because you start thinking horizontally, right? Okay, horizontally it is expanded, but in a vertical direction it's been compressed. Okay, that's why I hate using those. All right, so we're going to start off. We know how to do this now. We just did one. I always like to just do the vertex first, so this will be x plus 8 squared plus 2. Right? Because once we figure out a, I'm just going to go back, stick it in there, and then I'm done. Right? That's my thing. So now I put in the point 7, 3. And the y value is? 3. I'll let you say it this time. And the x value is? Okay. Actually, it didn't come out to too bad a number, right? So what do we got? 1 is equal to 225a. So what's a? 1 over 225. Actually, fluked into a pretty decent number there, right? I didn't know. I know you didn't know. So, but it came out to a nice number. And we would just leave that as 1 over 225. That's exact. We don't end up having to string out a number of decimals, right? I mean, 1 over 225 probably is a reasonable decimal, but, you know, it's definitely terminating because this is rational, you know, whatever you call that, you know. All right, so y is equal to 1 over 225 x plus 8 quantity squared plus 2. It opens up. This is positive, right? That matches up with what we've got. Okay? So that's a nice one. That's what you would have seen in conics, but we don't do conics anymore. So,
What concept is you don't want to know? Why don't you want to know? Because I don't know.
Find the vertex if given a problem.
given 2 points.
Oh, wait. Why did those two points my base on the same sides my medium curve or on a different side? Let's do it under
Oh, and a partial equation. Oh,
Yeah. I can't just give you 2 points. There's too many possibilities, right?
straight line guys.
Okay, so you need at least one other piece of information other than 2 points. You need something else to go on. So the equation I'm going to give you is y equals ax squared plus q. So what does that tell you? Yeah, there's no horizontal translation, right? Okay. So what happened to the vertex? It's at 0, q, right? So the stretch didn't do anything to the vertex, right? Never does. The reflection, if there is one, didn't do anything to the vertex, never does. And then it just moved up q. So we know the vertex is at 0, q. And we're going to have 2 points. And the points are 2, 1, and 4, negative 5. So that was the first thing we're going to do. As reluctant as you are to draw these things. So it doesn't matter, right? It's not necessarily part of the solution, but you know, if something's worth a few marks, you also got to look at that when you're writing a test. What's it worth? If it's worth 1 mark, you're probably not doing all that much. Okay, if it's worth 3 or 4 marks, or if it's worth 5 marks, God, but I don't know if you've seen anything worth 5 marks, but if you've seen it worth 5 marks, you can expect there's a lot of work involved in there, and you better be showing a lot of work, right? Because obviously there's a lot to do. So a 5-mark question does not get away with 2 lines, or 2 lines, yeah. Probably not. Okay, so we know that the vertex, so let's plot the points first. So I got the point 2, 1, and I got the point 4, negative 5. So that tells me, and I know the vertex is at 0, q, so it could it be down here and open up? No, because I won't be able to hit those 2 points, right? So it has to be above this. Okay, it's got to be above here. And it's probably heading down like that, right? So 2, 1. And what's this point here? 0, q. Okay, so what don't we know in this equation? We don't know a. What else? We don't know q. If we have 2 unknowns, what do we need? System. We need 2 equations. Okay, do we have 2, well, we can get 2 equations because we have 2 x's and y, right? So this xy will give me 1 equation with an a and a q. And this xy will give me a second equation also with an a and a q. And then we'll solve that system and be done. Okay, so putting the right numbers in, we got 1 is equal to 2, is equal to a times 2 squared plus q, or 1 is equal to 4a plus q. Right?
What? Because he rearranged it.
Square 2. I thought you were writing the second one.
Wow.
I have no idea what I'm writing, apparently. And negative 5 is equal to a times 4 squared plus q. So negative 5 is equal to 16a plus q. Now the nice thing is, since both equations have to end up with a plus q, right? Because there's nothing modifying the q. Then we can simply subtract one from the other, get rid of the q, right? Or you could, you know, do some weird rearranging or whatever. But somehow you algebraically solve, right? So now we write out our system. So if I'm going to subtract, let's put the 16a up front. So let's maybe do it like this. 16a plus q equals negative 5. And 4a plus q is equal to 1. So 12a is equal to negative 6. And a is equal to negative 1/2. And q is equal to I think it's negative 1, but I don't know.
Negative, oh yeah, Q.
4 times negative 1/2 plus q is equal to 1. Negative 2 plus q is equal to 1. Q is 3. Okay, so the equation is y equals negative 1/2 x. Oh, wait, there was no p anyways, right?
Oh god.
Move this down a bit.
Dun-dun-dun.
Whoa, let's make
Holy,
this
so
big.
big.
Move this down a little. Okay. Yeah, right. I was trying to erase, right? Negative 1/2 x squared plus 3. Now, how would you verify that? Well, you could go and say, all right, let's put in the x value of 2. 2 squared is 4 times negative 1/2 is negative 2 plus 3 is 1. So that gives me the 0.21. And I want the 0.4 negative 5. Put a 4 in there. 16 times negative 1/2 is negative 8 plus 3 is 5. So, yeah. Okay. Works for both equations. And we have our information. If you're given a graph, right, physical graph there, then you can do a couple things with the graph, right? You want to find the vertex, so you find the vertex off of the graph, right? I mean, it should be on a nice point. Here, let's sketch out. So if you're given a graph on a grid, you should be able to figure out the vertex. So that gives you P and Q, and then they'll give you a point usually. And that gives you an x and a y, and you just substitute all of that into the equation, and away you go, right? If you can count, over 1 and down, that'll give you your a value. If it says algebraically determine, you're going to have to show, at least you'll know the a value, and then you'll calculate it, and it won't be a surprise. Right? Hey, a is negative 2. If I don't get negative 2, I'll be surprised, and that means that you know you made a mistake. You can fix it. Right. Done.